For this problem, we are going to start with two identical transformers, each with a rating of 5 kVA and a turns ratio of 2 to 1, at voltage ratings of 200 volts primary and 100 volts secondary at 50 Hertz. This time, we're going to connect them in what is referred to as open delta, like this. Furthermore, the primary will be connected to a balanced three-phase power supply. Now, just as a reminder, the voltages of a balanced three-phase supply are equal in magnitude, 120 degrees apart, and rotating counterclockwise. In this arrangement, the phase-to-phase voltages will look like this. Our task in this problem will be to calculate the kVA rating of the open delta bank when the high voltage side is used as the primary. In an open delta connected transformer, each coil is connected across the lines. Therefore, the line-to-line voltage to be applied to the high voltage side is 200 volts. The induced voltage in each coil has to be 100 volts on the low voltage side. Since the low voltage coils are also connected in open delta, the line-to-line voltage on the low voltage side is 100 volts. A careful look at the circuit shows that both the high voltage and low voltage coils are connected across the lines, in other words, connected line to line. And since the secondary of the transformers are linked magnetically to the primaries, they too will have a balanced three-phase voltage at 120 degrees apart, rotating counterclockwise. The phase turns ratio is 200 to 100, or 2. The rated current of each high voltage coil is 25 amps, and the rated current of each low voltage coil is 50 amp. Thus, if we want the transformer not to be overloaded, the line currents on the low voltage side must equal or be less than 50 amps. Therefore, at the maximum rating, IS, the line current on the secondary side, is 50 amps, and the max rated line current on the high voltage side, IP, is 25 amps. Let us calculate the kVA handled by the bank of two single-phase transformers. On the low voltage side, the kVA going out will be given by the formula, the square root of 3 times the line-to-line voltage times the line current, and then plugging in our actual values, we get the square root of 3 times 100 times 50, which equals 8.66 kVA. On the high voltage side, the kVA supplied will also be given by the same formula, the square root of 3 times the line-to-line voltage times the line current. Plugging in our actual values, we get the square root of 3 times 200 times 25, which also equals 8.66 kVA. The total kVA available as open delta is 57.7% of the delta-delta connection capacity of 3 single-phase transformers, which was or is 15 kVA. This brings up another point of interest. If a bank of 3 transformers, each rated at 5 kVA, are connected in a delta-delta configuration, and for some reason one of the 3 transformers in the bank fails, it can be removed and the power can be restored, but the limitations on the new configuration, which is now an open delta, is just a little over 50% of what it was with the 3 healthy transformers, because the total kVA available as an open delta is 8.66 kVA, which is only 57.7% of a 15 kVA bank. In recent years, the reality of climate change has become impossible to ignore. Severe weather events are growing more frequent and more intense. For homeowners, this means that utility power outages are no longer inconveniences. They can last for hours, days, or in extreme cases, even longer. The question is no longer if, but when. You'll need a solution to keep your homes powered and your family safe. Now is the time to prepare and ensure that you're not left in the dark when the next storm hits. Here are some trusted resources to help you prevent power outages at home. 𝐃𝐈𝐒𝐂𝐋𝐀 Canada at this web address, 𝐃𝐈𝐒𝐂𝐋𝐀 USA at this web address, 𝐵LUETTI Canada at this web address, 𝐵LUETTI USA at this web address, and 𝐵LUETTI Australia at this web address. And finally, you can get EcoFlow at this web address. Ready to go beyond just solving problems? If you've been following my daily post and enjoying the sample problems, you're going to love this. All of these problem sets and more are now available, or soon will be, on my official course site. My stands for electrical training. Just go to the web address that you see at the bottom of this slide, https://stand.store/GVB.